Hi everybody, today we're going to look at the Chi-Square Test for Homogeneity, and we will use Minitab to help us perform our test. The Chi-Square Test for Homogeneity is used to determine whether two or more populations have the same distribution of a categorical variable. It is commonly used when data are collected from different groups, and we want to see if their responses or behaviors are statistically similar. For example, an engineer might use it to test whether defect types occur at the same rate across multiple production lines, or whether customer satisfaction ratings differ by region. This test uses sample data arranged in a contingency table and compares observed counts to expected counts under the assumption that all groups are alike. When we get to Minitab, we'll be using the Chi-Square Test for Association. Let's look at a few examples. An electrical engineer is comparing the types of failure, power surge, overheating, or component fault, in three brands of power supply units, or PSUs, alpha, beta, and gamma. The engineer wants to determine if the failure types occur in the same proportions across all brands. The data collected shows that alpha had 18 power surge failures, 25 overheating failures, and 12 component fault failures. Beta had 22 power surge failures, 20 overheating failures, and 18 component fault failures, while gamma had 20 power surge failures, 30 overheating failures, and 10 component fault failures. We're going to test the hypothesis that the distribution of failure types is homogeneous across the three brands. We're going to use a 0.05 level of significance. The first thing we need to do is state our hypothesis. Our null hypothesis will be that the distribution of failure types is the same across the PSU brands. Then our alternative hypothesis, that we can call HA or H1, is that the distribution of failure types is different across the brands. In Minitab, remember to label your columns so you have easy reference when we're clicking the different options. We're going to go to Stat, Tables, then Chi-Square Test for Association. Let's change to Summarize Data in a two-way table. And then we want to click the columns containing the table. That would be C2, which is alpha, C3 beta, and C4 gamma. On the rows, we also want to click the column with the row labels, which is C1 failure types. Now we select OK. The first thing we see are the observed values that we put in. Then the next row is the expected values that Minitab calculated for us. As we scroll down, we see the Chi-Square test. We only want to look at the Pearson row. We have our p-value of 0.331. If you need more decimals, remember you can click on the arrow next to the Chi-Square test table, go to Table Options, and change the number of decimal places that show. Our p-value is 0.331. Since p is greater than 0.05, we are going to fail to reject the null hypothesis. There's no significant evidence that the type of PSU failure depends on the brand. Let's look at one more example. A mechanical engineer is evaluating the wear patterns of a new type of brake pad used in three different car models, X, Y, and Z. After 20,000 miles, each brake pad is classified as showing light, moderate, or heavy wear. The engineer wants to know if the wear pattern is the same across the three car models. Our null hypothesis is the distribution of wear pattern is the same across car models. The alternative hypothesis is the distribution of wear pattern is different across models. The engineer's data revealed that Model X had light wear in 25 cars, moderate wear in 20 cars, and heavy wear in 15 cars. For Model Y, 30 cars had light wear, 15 had moderate wear, and 10 had heavy wear. Then in Model Z, 15 cars had light wear, 25 had moderate wear, and 20 had heavy wear. Let's find out if there is evidence that the wear pattern differs among the models. We'll perform our Chi-Square test for homogeneity at the 0.01 level of significance. Once again, we enter all of our information into Minitab, remembering to properly label our rows and columns. We'll go back to Stat, Tables, Chi-Square Test for Association. We have our summarized data in two ways. You're going to select your columns, C2, C3, C4, that have our columns containing the table. Then select C1, the wear pattern, to show the column with row labels. This returns a table of observed and expected values. The Chi-Square test shows us we have a test statistic of 10.664, 4 degrees of freedom, and a p-value of 0.031. Because P is 0.03, or 0.031 if you want to be more precise, we can see that P is greater than 0.01. This means we do not reject the null hypothesis. There is not significant evidence that the distribution of wear pattern is different across the car models.